So I was looking around online for some bench power supplies, but they were all too bulky and expensive. And I wanted something customizable and small for when I inevitably get bored of it. And that's when I got to thinking, I could build that. And if I'm building it, why not just make it USB-C powered? After some digging around, I found that the ZK4KX buck boost converter and a fast charge spoofing module will give me everything I need. And with some support components, that's a bench power supply. So let's build it. So here's what you'll need. A constant current, constant voltage buck boost converter with a screen. This will be the brains of the operation. We'll also need a power delivery module to negotiate voltages higher than 5 volts out of supported USB-C power supplies. We have some banana connectors for our outputs, and finally a project box. I've chosen this one because of the slanted front and the aluminium, which makes the project look a lot more sleek. Along with all the components, we'll also need some wires to connect everything up, and I also got some banana clip to crocodile clip connectors so that I can connect things a bit easier. Okay, we get it, you have ADHD, come on. Hey, pay attention. So we can pretty easily use a piece of paper as a stencil to mark out exactly where we need to cut later on. This also gives me the opportunity to see if I'm the artist I really think I am. I really do think I am. I know my parents don't agree, but I think this is a brilliant piece of art that actually could, be put up at a museum or something. For the fan, it was easier for me to just eyeball it and mark it down with pencil, and then proceed to completely ignore those lines when I'm busy actually cutting it. For the aluminium panel, I cut this off screen due to the messiness and aluminium shards which will be launched at you at high speed. At time of recording this voiceover, I still have shards of metal in myself. Oh look, great transition, that definitely went in perfectly fine and didn't require any further adjustments to the front panel. Trust me, I'm the narrator, I'd never lie to you. So what we're doing is just cutting some cables and soldering them to the power delivery module, and we'll take the other side of these cables and put them into the input side of the buck boost converter. These will then be fastened for a very short amount of time before I realize the fan actually also needs to go into these terminals. But we'll talk about that later. For now, I'm just busy quickly attaching wires to the banana terminals with their corresponding colors for positive and negative. The other sides of these cables will be connected to the outputs of the buck boost converter. Why is the cable purple and not red? Well, firstly because purple is my favorite color. Secondly, because they were out of stock of red. So, apologies, you'll have to deal with purple. That's also why the input has orange, but we'll just pretend this was a stylistic choice. Oh look, we're connecting the banana terminals to the outputs of the buck boost converter. So what I'm doing here is just making sure that all of the holes line up with the holes in the case and that the fan's blade can turn without scraping. What we'll be doing to attach this is using self-tapping screws that'll go through the protective grid and into the fan. And now's the time to come completely clean. The only reason I bought this fan and protective grid was because of the adorable filter that you can see on screen right now. So you can see me taping down the speed sensor wire, and this will be used in the future when we upgrade this bench power supply to have more features. And yes, this is the third time I've had to detach the power delivery modules from the buck boost. But at least after doing this, it becomes pretty easy to push the module into place, stick it down with some hot glue, and then reattach everything with the fan connected this time. Yes, I'm shaking. I had a lot of caffeine on this day, and I think you could notice. I'm just applying copious amounts of hot glue, as I have no idea how I built this with the aforementioned amount of caffeine in my system. Oh look, return of the shaky hands. Now with some consensual screwing, we can wrap this up quite quickly. Okay. Yep. Okay, awesome. Now we're over to testing. So one of the things that impressed me about this module is actually the accuracy. We see on the multimeter 5 volts, we see on the buck boost converter 5 volts. What I've done is I've placed a battery there for testing, so what I'm doing now is adjusting the constant current, constant voltage to match the parameters for this particular type of battery. Or as close as my ADHD brain was willing to let me go before I got bored of clicking the buttons. Wait, isn't that a different battery? Why do we have another battery? Well, as you can see, it's working at least, and the proof is in the pudding. Fuck, I wish I had some pudding right now. But pudding aside, now that everything's working, we can officially add the logo and start the real testing. Using a 10 watt 2 ohm power resistor, we're just busy testing how much current we can draw while attached to a USB power bank. It looks like that number is just under 2.9 amps. Running the same test, we can see that we can reach about 3.6 amps before the power brick cuts off the power. Since you made it this far, maybe consider leaving a like and subscribe on the video. And since you're here, maybe help me with this? I kind of hate it. So leave a comment if you know what I should put in my background. But thank you guys for watching, and I'll see you in the next one.